Hi, everyone, and welcome to today's webinar, From Decision Analysis to Mindfulness, Letting Go to Improve System Development with Dr. Alejandro Salado. My name is Donna Long, and I will be your host during today's webinar. Alejandro is an assistant professor of systems engineering at Virginia Tech. Before joining academia, he spent over 10 years as a systems engineer in the space industry, developing and leading space systems of up to $1 billion. He is a recipient of the Verbicki-Blanchard Award for Systems Engineering Research from Stevens Institute of Technology and the Fulbright International Science and Technology Award. He holds a PhD in Systems Engineering from Stevens Institute of Technology. He is a member of INCOSE and a senior member of IEEE and IISE. Before Alejandro gets started, I have a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Alejandro will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be available within 1 business day of the live version. The recording will be published to Vitek's webinar archive, located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Now I'm going to turn the presentation over to Alejandro. Welcome.
Okay, thank you, Donna. So I'm happy to be here with you guys, trying to share some ideas of bringing decision analysis and mindfulness into system design. And I guess the first question is, why do we talk about these two things, together? Look at the picture. Mindfulness seems to be about relaxing, having peace of mind, going to the beach, enjoying some quiet time. But decision analysis is about numbers. Look at the decision tree. Lots of branches, characterizations, computation and calculations you need to do. So why do we bring this together? And of course, the first answer might be that I'm this guy trying to break silos and looking at, hey, let's see what other people do, how they do it. Because in my experience, most people work in their own domains doing the same things as the other people. So there may be some things we can learn from them. Now, some of you may also think, hey, I know where this is going. Decisions are tough, right? We're in a company, it's really, we face very difficult problems, tight schedules, lots of pressure to do this stuff, and mindfulness might be good to just go and relax, right? That's a picture of the Google Zurich office, and you can see how these guys are just relaxing after, I guess, some difficult times. But this is not really the link I want to offer in this seminar. Rather, what I'm interested in is in exploring if we can learn something from decision analysis and from mindfulness that can help us do better systems. Okay. So let me present you what mindfulness is. And I got into mindfulness because my wife got into it, and she was explaining to me many of the things she was learning, and I was keep on thinking, hey, wait a minute, many of those things, actually I do it also. I just call it decision analysis. Okay. So several people think that mindfulness is actually meditation, but it is not. Okay, mindfulness is a state of the mind. It's a behavior that we pursue in life, and the ultimate objective is basically to be happier, feel better with oneself. So some authors have come up with 7 attributes of mindfulness. So mindfulness is not about doing one thing, but it's about exhibiting certain attitudes to life. Okay. So one of them is non-judging. Okay. And what this means is that you want to be an impartial witness of your own experience. You want to avoid the constant judgment of how we do things good or bad. Okay. It is about really saying, I am who I am. I'm not going to be judging everything I do continuously. The second attitude is patience. And here what we mean is, you simply accept the fact that sometimes things must unfold in their own time. Okay. There are things that we cannot control, so there is no point in worrying about them. The third attitude is having a beginner's mind, which basically means we want to have an open mind that allows us to be receptive to new possibilities. Okay, we do not want to be this grumpy person saying like, "Oh no, we've always done it like that," right? Rather than this, it is a mindfulness attitude to simply say, "Hey, let's try that out. It may work, it may not." The fourth attitude is trust. And the idea here is that we want to trust ourselves and we want to trust our feelings. Okay. Um, when we believe certain things, it is for a reason. So it is not good in general to just think about ourselves as lower as we actually are. The fifth one is non-striving. And non-striving means that mindfulness is not done for the purpose of mindfulness. The goal of doing mindfulness is to be yourself, not to change you. Okay. Mindfulness is not about saying you have to be more relaxed. You have to change the way you behave in this situation. It's actually defining yourself. Okay. It is about trying to avoid that the context, our environment, makes us behave in a way that it is not us. I go to the sixth one, which is acceptance, and this is a critical one in which basically we want to see things as they actually are in the present. Okay. We waste lots of time trying to deny or resist what is already a fact. And what mindfulness says is there is no point in doing that. Facts are facts. They exist whether you like them or not. So the best thing you can do about them is accept them. And lastly, we have letting go, which is kind of the core of this presentation. Now, the thing is that the mind wants to hold on certain feelings or thoughts that limit yourself from enjoying the present or capitalizing on opportunities to enjoy the future. And we simply need to let them go so that we can really enjoy the present or capitalize the future. Okay. Several people are anchored to the past and they do not enjoy the future, the present. So this is what mindfulness says, is that if you really want to do mindfulness, just try those 7 attitudes in your life, you will be happier. Okay. Now, I'll tell you something. All of these attitudes have a very precise equivalent in decision analysis and decision making, which is pretty cool, I think. In essence, a person that is driven by decision analysis is actually doing mindfulness, even if they don't do it, if they don't know it. For example, when I talk about non-judging, this is related to avoiding doing advocacy analysis. Okay, just focusing on characterize the decision you have at hand. Do not try to pursue a path you think you have to. Just be open to the different alternatives. Patience has to do with the notion that if a decision is good, then there is no rush for the outcome to materialize. Every decision is made in the face of uncertainty, and you cannot control uncertainty. So there is no point in being unrelaxed about it, but just embrace uncertainty and live with it. Having a beginner's mind, being open, is critical to enable creativity. You want to try and identify as many alternatives as possible. The more you search the solution space, the more chances you'll have to find a preferred alternative. And therefore, you really want to have an open mind to explore them. And I guess you've seen lots of pictures these days, LinkedIn, Facebook, Instagram, and all that, with the typical sentence, we've always done it in this way and so forth. You want to try to avoid that. Okay. And that's key in decision analysis. We move to non-striving, and that can really be mapped to the purpose of decision analysis, because decision analysis is not intended to tell you what to do, to force in one direction, but to give you clarity of what is better for you, what you prefer. Okay, and that's essential in decision analysis, and it's really equivalent to the non-striving notion that we have in mindfulness. We go to acceptance, and it has really great implications in decision analysis. The first one has to do with framing. Whatever is given is given, so there is no need to discuss about it. I tell you something. When I do my consulting sessions in industry, this is really something that strikes me when people discuss. They go rounds and rounds, circles and circles, discussing things that either are not related to the decision, they do not affect the decision, or they are simply facts. So there is no point in discussing them again. Okay. The second one is the notion that the quality of a decision is independent of its outcome. Now, this one, it's tricky to get across, but once you get into the core of decision analysis, this notion is essential because decisions are made in the face of uncertainty, and you cannot control how the uncertainty will materialize. The quality of your decision cannot be measured on the outcome, but rather on the process that you follow. Therefore, there is no regret if the outcome is not preferable. It's just, maybe unlucky. You're being unlucky. Now, the last one is letting go, and that's the center of this seminar, which is the sunk cost trap. And I'll move to the next slide to tell you, to show you what I mean by this. So consider the scenario in the slide, which probably some of you have experienced at some point. So basically, you decide to go to the movies, you spend $10 for your ticket and go see the movie. After 30 minutes, you are really bored. Let's put it simply, you do not like the movie. However, since you've spent already the money for the ticket, you stay and watch it until the end. Hey, you paid for it, right? So who would do the same? This story is really interesting. And actually, the first time I heard it was when I was in my first year of undergrad, because my wife was studying economics. She's an artist now, but she really started her undergrad in economics. And her professor put this problem to them. And it is really interesting because most people say, hey, I paid for the ticket, so I'm going to watch the movie. Okay, I paid for it, so I want to get the reward, right? But the situation is the following. The first point is that you've already wasted your money. So there is no way you're going to recover that, right? The decision to continue watching the movie or not watching it is not affecting the fact that you have already spent it. If you stay and watch the movie, you're also going to lose your time. While if you leave, at least you will have your time to do something that is more valuable to you. So actually, from a decision analysis perspective, not watching the movie is a much better decision, simply because you are not wasting your time, you are making use of that, and there is nothing you can else about your previous investment. And that's one of the key principles in decision analysis, which says a decision should only be made based on future prospects, not on past investments. Okay. Whatever we invested makes no difference to the way the future is going to look like, and therefore we should only evaluate what the future will yield, irrespectively of what we have spent so far. In decision analysis, this is known as the sunk cost trap. Okay. Now, most people will not make optimal decisions only because they remain anchored to the past. And I'll tell you something, guys, this is a cognitive bias almost. It happens to most of us, it's difficult to control, and we see it in so many situations in life. I'm going to give you some examples, but they are really plentiful. You go to a restaurant and you order food. You are not really enjoying it, but hey, you pay for it, so then you eat it entirely. Or even worse, you are not really hungry, but come on, you pay for it, so let's finish it. Another one, you've trained really hard for this game, so even if it is raining and windy and you are really, really uncomfortable, you're going to play it, just to conclude the purpose for which you train. The last one is even more personal. You hate to see your partner's face when you go home, but since you've been for 26 years together, you're not going to divorce, right? And you can see this, and probably you know people doing that, and they're not looking at what the present looks like. They're not looking at the prospects of that the future may yield. They're simply saying, because I did all of that, I'm going to continue doing it. I've got several students here actually saying the same thing. I'm not really enjoying this degree, this program, but since I've already studied for 2 years, I'd rather finish it. Well, that's the sunk cost trap. It's the same situation as in the cinema. If you're not enjoying it, you have never worked, in that profession, why do you lose 2 more years? Just switch and do something that may yield a better future for you. And this really leads us to the core of our seminar. Engineering projects and companies are plagued by decisions that fall into the sunk cost trap. And I'm going to share some of them with you. So, coming back to mindfulness and decision analysis, this is why we're bringing them together. Both of them are telling us that you must let go. And actually, I'll try to convince you today that letting go really results in improving system development. So now, why is that? Well, there is one main reason for it, and is that engineers love their designs. Okay, they love them. My first experience as an engineer showed me something really interesting. Whenever a new engineer will come to the project, they will look at the design of the previous engineer and say, this is not that good. I can do better. Okay. And this is sensible, right? I mean, an engineering artifact is the creation of an engineer. It's the product of their minds. It's the results of many hours of work. So you get attached to it, right? It's like if you have a kid, you get attached to your kid no matter what he does. An engineer behaves in the same way with their engineering artifact, okay? Actually, even if I think about managers, it's the same situation. They've got the decisions that were made, and maybe they were agreed after several hours of discussion or days. They've got contracts. So we have situations in engineering programs in which engineers, managers, in general team members create emotional attachments to the things that they develop. Unfortunately, the world is changing rapidly. There is a very dynamic environment for system development. So then the question is it possible that some engineering or management decisions associated to the system development may become suboptimal or inapplicable as the development evolves? And this is actually the source for letting go being a key attitude in system development for achieving success. We need to recognize that because systems are developed within a changing dynamic context, some decisions may need to be revisited. Now, this is not for criticizing one's work. This is not about saying that one design is better than another one for the original problem, or that the original is bad. The notion of betterness actually changes with context, information, and purpose. Hence, several decisions need to be revisited, not because they were wrong, but because the new context, the new information of that new purpose make it suboptimal with respect to other alternatives. And I've seen this so many times, right? Because we get attached to our designs, we get emotional. We believe that if someone is trying to change that sometimes later, it's because they're criticizing our work. But that's not the case, right? A decision is made based on a given context, a given purpose, and a given state of information. But if things change, well, then maybe there is a new need, that there is a new alternative that is going to be better. I did a master project with one of my students, and it was really interesting because he really tested this. He posed a context to people in the company to say, hey, could you please recommend the best solution? And, the team members provided the recommendation. 2 weeks later, he presented the same situation, but with a different context, different information. None of the team members changed their recommendation, okay? So you can really see the level of attachment that we get with our own decisions. Irrespectively of how the world changes, we still believe that our device, our solution is the best one. And we really need to change that context of betterness because it really depends on where we are. I'm going to try and show you a few examples of my experience in which this happened. Okay, they really they fell into the sunk cost trap, and then they had bad consequences. I'm going to try to cover as many parts of the life cycle as possible. Now, note that the examples I'm going to give you are not made up, and they're not academic. They've been really taken from my experience in industry before I joined academia. And of course, I will not mention the specifics about the project names, the companies, the exact values, so everything is going to be sanitized, but I'm sure that most of you will have experienced similar situations and will resonate with the examples that I'm going to cover. Let me start with requirements, and please do not disconnect at this point, okay? I know that most people don't like them, but it's just only the first example. So the company I was working for had invested a ton of money to adopt a requirements management tool and spread it throughout the company. Now, as usual with these efforts, this did not only include purchasing licenses and managing the technological infrastructure, but also training most of the individuals that were working with them, adapting existing processes for requirements management into the new environment and so forth, okay? Now, the process was quickly adopted in one of the projects, and the team started to create data models filling the database with requirements and relationships. So that's awesome, right? I mean, You have a team that embraces requirements. Who doesn't want that? They really did an amazing job. Lots of requirements were put into a database. Lots of relationships were created. Now, a few months went into the project, but unfortunately it turned out that the approach they followed had some initial major flaw. And in fact, it was not really recommended to use the requirements that they had generated, but instead, it was recommended that they would start over from scratch to guarantee that they had an adequate problem formulation. Okay. However, the team had some concerns. They didn't like the idea. Why? Well, they had put a lot of effort on generating the requirements already. And as a matter of fact, they had consumed almost all the budget that came into the requirements work package. In addition, the company had made a significant investment, so the process had to be used. Now, look at what I've said. The team complained that they had put a lot of effort, they had consumed already almost the entire budget allocated to the work package, and the company wanted this. None of them looked at the consequences of continuing with this process. And actually, this is what happened. First of all, the database became significantly ineffective to do proper requirements management. And second of all, the holes that they had in the requirements, they yielded changes that were heavily more expensive than having simply redesigned the requirements structure. Okay. So again, this is an example of the sunk cost trap and the consequences that it has. The decision was, shall we redesign or continue? They should have considered, let's look at the risks and investments ahead. Instead of that, they focused on what they've spent already. Okay. Let me go to a second example, and this is one of my favorites. Okay. The team had prepared a concept for a satellite payload under a feasibility concept study for the government. They had spent 2 years in such an effort, and it was time to write a proposal for going ahead and implementing the payload. Now, for the concept study, the main target was to achieve certain level of performance. Okay. So the concept design that they managed to get, which actually was heavily praised by the government, was targeted at $300 million price. However, the request for proposal from the government for the implementation phase was a bit different than the conditions for the concept study. In particular, they was really concerned about price, so they set a target at $250 million. Okay. Now there is led to the question of how to proceed. Do we propose the one that we've done in our concept study, or do we do a quick effort and come up with a new idea that fits the conditions of the request for proposal? So some colleagues and I were called in to audit the first steps in the proposal. Now, given the new conditions of the RFP, our suggestion was, well, let's completely change the design because we do not really have a chance if we offer the $300 million one. It is basically infeasible. The team actually corroborated that, but they stated that, you know, given all the effort that they had spent in the concept study, they could not simply scrap it. How could they trash the design? You know, I mean, are you saying that we're not doing a good job, that our payload was bad? And, you know, as a matter of fact, we already have a design. So why invest more in doing a redesign effort? Okay. Now, again, you can see the keywords that they're using, you know, trashing out. Did we do bad? Are you saying, you know, that you could have done better than us? We've already designed this and spent a lot of money in doing this concept study. So how can you tell me we're not going to reuse it? Okay. So the team ended up proposing the $300 million. Of course, we lost the contract, and the competitor took one that was cheaper and fit, you know, the budget constraints. So hopefully I can see you again. Another example in which the team fell into the sunk cost trap, focusing on what they had done to justify their decision instead of looking at future prospects to find the best alternative. Let me see. I'm trying to pass my slides to the next example. Okay, there we go. And the next one, I'm bringing contracts also. Okay. So managers are not going to be quiet. It's not all because of engineers. Now, this one is related to the development of satellite And this particular satellite was going to orbit in a radiation critical environment. There were significant concerns about some environmental properties that could happen inside the satellite. Now, taking a conservative approach, it was decided to implement a heavy shielding in the harness of the satellite, which made the harness really expensive. Okay. Unfortunately, they didn't have more information than that. So that was kind of a good decision at that point. Now, sometime later, with the design of the harness quite advanced, but still far from manufacturing, spin-off team faced a similar situation in another project. Now, this time, they actually had the time to go and do some sophisticated analysis. Okay. And what the analysis showed was that actually there was no such concern in the orbit they had chosen, and this heavy shielding wasn't necessary. Okay. So we went ahead and asked the team, hey guys, we know that you've designed this. It is quite advanced, but you've not manufactured it yet. So maybe you can save some dollars if you actually remove the heavy shielding and just use traditional harness, right? It looks like a good idea. I mean, you don't need it, so why are you going to spend, some budget on that? Now, the team said the following. First, it took a great effort to make the decision actually, so they don't really want to revert it. And in fact, the contract had already been signed. They had a design, and they invested dollars in designing the overshielding. So they didn't want to change it. And actually, they didn't. The result? Wasted resources. Okay? For sure, they had already took the effort, they had already invested in the design, but that money was not going to be recovered. What they actually did by making the decision to stick to using the heavy shielding was wasting unnecessary money in material effort, manufacturing effort, and integration effort. Let me go to another one, and this is related to architecture. Okay. Now, this is another curious situation in which good ideas get lost in the way. So in this one, a team is developing an optical instrument for a satellite. So let's take that for, as an example. So you have a telescope, you have a filter, a camera, and a computer. And there was high uncertainty in the reliability of the camera. So it was decided to proceed as follows. Okay. Let's first architect the system so that the camera is redundant. Okay. So we're going to consider from scratch that we're going to use two cameras. And in parallel, we're going to do an accelerated lifetime testing to really get to determine what the reliability of the camera is. Okay. And this idea is good. Now, the problem was that the entire project ran with the design solution of two cameras in redundancy, not as an option, but as a hard stone decision. Now, shortly before manufacturing the flight hardware, the results of the accelerated lifetime testing came. And it turned out that the reliability requirement of the instrument could be fulfilled with just one camera. And therefore, the second one was not necessary. Now, part of the team went ahead and suggested replacing the second camera with a mass and thermal dummy, because this could provide significant cost savings. First of all, you have to manufacture less hardware, right? Now you only need one camera instead of two. Second of all, you have a faster integration. You have just a dummy to put in place and not doing an alignment and so forth. But also you have less testing to be done and calibration because you only have one camera. Unfortunately, the team said, yay, but it's already in the design we committed to the customer. So we keep it. Again, in this case, I hope you see how the team fell into the sandbox trap. They didn't let their initial decision go, and instead of letting the second camera go, they kept it just because they had committed to have that camera into the design, even though it didn't contribute at all to fulfill the requirements from the customer. And I'm going to the last example, which is actually a little bit funny. So we were developing a communication satellite. So you can see it there. And this communication satellite was integrated a secondary payload. And the secondary payload actually generated heavy concerns on certain performance of the satellite. Sorry, I cannot give you the details of this one, but let's simply talk about, vaguely about critical performance. So the team developed a dedicated testing device to measure that specific performance efficiently during satellite integration. And this is because the integration and test schedule was really tight. Okay. As you can see there, we had integration of some primary payload. Then we had some testing on the secondary on the primary payload, integration of the secondary payload, and then we would test the critical performance, continue test campaign, and deliver. And the testing device was actually awesome. It was very beautifully crafted, and it was really an improvement over the state-of-the-art in measuring techniques for this type of performance. It was really, really an amazing piece of engineering. Now, when the satellite was being integrated, however, it turned out that the secondary payload was not going to be able to make it on time for the launch of the satellite. And it was decided to launch the satellite without that secondary payload. One improvement, of course, is that we didn't, we saved time just because we didn't have to make that effort. But the interesting aspect is that the original concern wasn't a concern anymore, because the critical performance was created by the secondary payload, which was not going to be part of the satellite anymore. So then the question came, hey, if you do not have that concern anymore, is it actually worth doing the test at all? Now, the verification team proposed to remove the test that required that special test equipment. Now, that test equipment was awesome, but was not going to be used if our proposal was going to be accepted. Now, this would actually save more time and provide contingency to a very tight schedule for the project. Now, once again, the management team opposed to reducing that because the company had invested a lot of money in this device, and we cannot tell the customer simply that we're not using it now after we spend all that money. So actually, the team carried out the test just for the sake of using the device, with no value whatsoever for the project. And again, this is a sunk cost trap faced again during a test sequence. So I've shown you a few examples on the requirements realm with formulating problems. I've shown you an example with acquisition and implementation, one related to architecture, one related to integration and testing. And criticizing is easy, right? Like finding problems, it's extremely easy. So what about solutions? What do we do? As I said, this is really kind of even a cognitive problem. We don't know about it, we just fall into the trap. And we have to be extremely attentive to avoid doing that. But there are two things we can do. So the first solution is to adopt decision analysis formally. And I know that this is a great weakness because, as a matter of fact, we leave our engineering programs without any formal education in decision analysis. Yet, most of the work we do is actually making decisions. So you can see a decision tree mockup in the slide. Now, by modeling the situation, it is really easy to avoid falling into the sunk cost trap, because the model itself will remove the effect of past investments. In that way, we can really focus all of our attention in the future prospects resulting from the decision that we're facing. Now, I'm not going to go into the details of decision analysis. That's not the purpose of this seminar. But feel free to contact me after the seminar if you want to learn more about how to apply decision analysis in engineering. I'll tell you something though. Learning how to do high-quality decision analysis in engineering is a game changer. I have experienced it myself when I was working in industry and I learned it. I see it every week with my students in class, and I've seen it several times when consulting in industry. Okay. So just to give you a very short feeling of how the decision tree would have, helped you avoid the sunk cost trap, when you look at the choice and you are characterizing the alternatives, you just look about what will happen next. And that's kind of the idea of the decision tree. I'm looking at the consequences only. The model doesn't let me model the past when I'm making the decision. And therefore, it really helps me avoiding that. Now, the second option is to really formalize temporary decisions as options, not as design features. Okay. Now, documenting is painful. We all know that, but it is necessary. A common problem, however, is that we have to document so many valueless bureaucratic stuff that we fail later in documenting aspects that are really critical to the project. Okay. So what happens is that often we anchor to a best alternative at a point in time and then document it as the nominal solution or current design. This leads to an emotional acceptance and anchoring as if all the effort that is being done is for the solution itself, not for the project. And that makes us lose sight of what the solution actually is, which is simply one more element of the development strategy to achieve success in system development. Okay, and that's really important. Everything we do in design, in system development, is not for the sake of the system. Okay, they are simply elements we have as part of a higher level strategy to achieve success. Therefore, it is way better to discuss always in terms of options. Instead of saying we are working with a nominal solution, we are working with the current design, we must say we're working with option one, which is only valid until 10th of October 2020, in which we have to see if the applicability is still valid or not. Okay, I'm going to show you 3 examples where formalizing options was instrumental in avoiding the sunk cost trap. In the first one, we were defining an integration sequence for an optical instrument. So you have their mock-up steps, right? Now, one of the performance of the instrument depended strongly on the number of iterations that were executed in a specific activity. So the performance was not only a function of the design, but we were also depending on how many iterations we did in integration to improve the performance. You can think of it like a fine-tuning in few ways. The relationship was easy. The more iterations you would do, the higher performance you would get. Okay. However, our schedule was tight, and we were really concerned that integration engineers would fall into the sunk cost trap. They would say, oh, we have achieved this performance so far, with just a little bit more, we can get even better. Okay. So, as soon as one of them, so then what we tried to do was define criteria. What do we need out of this? And for the future, there were 2 things that we had to consider. First, performing better than the target was not providing any value to our project. Okay, so once we met the performance, we were good to go. Further improvement had nothing to do with the success of the project. And second of all, we actually would lose more from delaying integration, not from achieving the performance. So then we came up with 2 success criteria for the step. Oh, sorry for that. Either we achieve the performance target, or we achieve a maximum number of iterations and then we move forward. And this was written in the procedure. Okay, we really coded this as options, not as nominal. We didn't say our intention is to achieve the performance, and if we cannot, then we will move. We simply said there are 2 equally important success criteria for this step: achieving the performance target or reaching the maximum of number of iterations. As soon as you meet one of them, you move to the next step. Okay. And this way would really avoid the sunk cost trap. The fact that it took you almost no time to achieve the performance is not a reason for actually spending more time to further improve it. The fact that you're almost at achieving the performance is not a reason for actually continuing and completing that. Second example of how working with options was really good to avoiding the sunk cost trap. In this case, we were architecting an optical instrument. So there was a key performance that depended on one of the components of the system. Okay. Now, unfortunately, this key component was an development. So there was a very high uncertainty about the performance we could achieve in the amount of time that we had. We then opted for an architecture that allowed us to not incorporate the component if it wasn't ready, suffering then the key performance, but making sure we could deliver on time. So we were working with 2 designs, one with the filter and one option of it without the filter. What we did was, instead of simply saying, oh, what we have is a nominal design and a risk mitigation action, we formalized this in the design and development plan for our system. What we basically said was that at kickoff, we're going to start using design A for all of our analysis. but let's say 38 months later at time T, we'll have a decision gate to decide if we would continue with design A or we would change to design B. Okay. Now, essentially what we did was that irrespectively of the effort that we had put already into succeeding in the development of the new component, and irrespectively of how close we were to the required performance, we were going to have that decision point potentially opting out of design A. And we coded that as options, not as nominal design and secondary option, a non-nominal option, but really as, hey, we have two alternatives. Let's just have a decision point that is pre-agreed and predefined in our design and development plan. Of course, this doesn't mean that no matter what, we would choose design B, okay? And we would opt out if the component wasn't developed at that specific time. Because at that specific time, our state of information was probably changed, then we would make the decision again. It might have been that we said, well, given that we're close to the performance, let's use one more month to try and then we'll revisit the decision, okay? So do not take this as, I'm gonna take today a non-modifiable decision for the future. It's rather saying, I've got two actions. When the time comes, we can revisit that because my state of information has changed. And this leads me to the last example, and this has to do with testing. So you can see on the slide a verification matrix, a test matrix. And traditionally, the verification matrix for a project is agreed upon at the beginning of a project and signed as part of the acquisition contract. Now, you probably know that the purpose of verification activities is to discover knowledge about the system. At the beginning of the project, we do not know much about how the development will go. We do not know much about whether we will actually achieve the performance targets that we have. So therefore, the first verification matrix is actually based on best guesses and intentions at the beginning of the project, when our state of information is really, really low. But as we have discussed, system development is heavily dynamic. So who in the audience hasn't obtained unexpected results, for the better or for the worse, in an analysis or a test that actually made the test matrix or verification matrix change as we move, right? We had a second version, a third version, and so forth, okay? Now, usually, those changes come because you need more stuff, not because you want to descope some of the stuff you actually baseline. So in this particular project, we went one step further. Now, on top of defining the baseline verification matrix, we defined conditions under which we would consider baseline tests to be no longer necessary or non-baseline tests to be necessary. Okay. Specifically, we defined that the necessity to do testing was a function of the margin that we would see in the analysis, of course, for some of the parameters. If we obtain more margin than we expected for a given performance, we could consider avoiding a planned test, and vice versa. If we would see less margin than we planned for an analysis, we might have to consider a test that we didn't initially thought of. Okay. Now, as you can see now, the decision is not based on whether I had already planned to do this or I had budgeted to do this. It is based on I have new information and my uncertainty for the future has changed. So let's look at that to drive my decision. Now we come back to the beginning then. Now, mindfulness and decision analysis tell us to let go, to not think about the past, but think only about the journey ahead. I have shown you some examples from industrial experience that show that not doing the results in way, that not doing this results in waste of resources or in obstacles to capitalize future opportunities. We've also seen a couple of ideas about how to avoid the sunk cost trap. Do decision analysis formally and think always about the future, as well as creating options and formalizing them. It is really important to understand that the system development is a strategy, and any solution is just one element of that strategy. The purpose of system development, it is not the system, but it is success. And therefore, everything is tradable but success. So the last thing I would like to say to close is that when you face system development, be open and embrace the letting go mindfulness attitude and just focus on how can I capitalize on future prospects to maximize my success. And with that, I really thank you. And I guess I'm open for questions in case you guys have any.
Thank you, Alejandro. We do have a few questions, thanks to all our participants. I encourage everyone to join the discussion now and submit your questions using the webinar control panel. Our first question is from Chris. I understand your argument in the context of the requirements example. However, does the same argument apply in the design of something like a power plant, where to do something radically new may have very expensive consequences for the distribution grid?
That's a very good question. And, actually, that's part of the decision analysis. So the point of this is not saying, because I've invested so much on the power plant, I'm going to continue building it, but rather saying, what is the future that I'm getting with the current design? And what is the future if I change the design? And of course, that future includes the investment necessary to redesign the plant. But I will explore those alternatives based on future prospects of investing and return and continuing with my baseline and return, not based on how much I spent already in building the current situation.
Okay. Chris has another one. In the camera example, removing the camera that isn't needed sounds easy, but do you have any comments on the risk that that carrying out such a redesign might import to the project?
Absolutely. And it's really good that you, Chris, talk about risk, because that's precisely the point. Those are the type of things we want to consider in making the decision. I have one camera, so I have a design with two cameras. I have a risk for future scenarios and uncertainties. I have a cost associated to building the two cameras. And now I have an alternative, which is I build one camera, I've got some investment because of the redesign, and I have new risks because I have a new design. And I will look at those two things. But if you look at how I'm discussing, I'm talking always about the future, the characteristics of the alternatives from today to the future. I'm not incorporating that because we've already have this design, we have to continue it. Because I've already spent so much money, I have to keep the design. So it's the same concept. I'm not saying, and please do not take the message that given a point, the best alternative is to change. That's not what I meant. It is about saying, I'm not going to consider what I've done so far, but only the prospects of the future that I will face. And it might be the case that your decision is to keep doing what you're doing, and that's okay. But it will be okay as long as your decision is based on a better future than the alternative, not based on what you've done already.
Okay, and one last question from Chris. I was wondering how closely mindfulness corresponds to systems thinking. Is this something you have given any thought to?
Well, I'm thinking about that, and I've been thinking about that for a while now, and I think it is pretty close. The traits of mindfulness are very similar to the traits of systems thinking. You can think about embracing uncertainty, right, which is related to acceptance. Openness, right? Trying not to have your own view of the world by expanding that, and that's similar to be yourself, not try to be whoever how people look at you. So I think definitely there are traits that are similar from one to the other one. And as I said, because mindfulness is really about an attitude towards life, I think becoming a systems thinker, or like bringing decision analysis to your life, actually contributes for you to be more mindful from that perspective.
Okay. We're having some questions come in. Let me go ahead and ask one here. Question from Alex. You are saying that decisions should be taken based only on future prospects and that the past is irrelevant. But we learn from the past, from our mistakes and successes. How do you take into account that experience gained in the past then?
Right. So that's a great question. The idea is that, of course, the past is used for shaping our beliefs of the future, but it shouldn't be taken as a decision driver. So definitely we use the past just to inform our beliefs on uncertainty in the future, about characterizing the future, but not as a driving, anchoring element that we use to actually base the decision on. So just to put it another way, the past should not be a decision criteria, but should be information that I use to characterize future prospects.
Okay. We have a question from Eduardo. In the example of the filter, can you please comment about concurrent engineering from A and B against a modularity option where filter would be just removed?
Okay, right. So actually, that was the design. So we have two options, the two designs, and I mentioned that in a sentence, so maybe I wasn't slow enough. The key idea was that we made sure that the design enabled two options because with modularity. So it was really flexible enough to simply remove the filter and it would work out. Okay. Now the point is that you would say, well, I've spent so much time putting designing the filter, and how can you just assemble the instrument without incorporating the filter if I have it, right? So definitely the two options of the design came from the same architecture, which was modular, and the only effort was installing or not installing the filter. So
Okay.
the anchoring was to a desire to install it, kind of.
Okay. We do have another question from Thomas. I understand that you need to avoid considering past investments when making decisions. However, what if my customer is actually unhappy if I don't use some development they paid for, even if it is more costly to use than not to use?
Right. So again, this is information and we use it for the decision, but not as a decision criteria. So the idea wouldn't be to say, well, because my customer paid for this, I have to use it. It would be rather, if I use it, what is the impact that I will have in the project? And if I don't use it and my customer gets unhappy, what's the impact of his unhappiness? Okay. And again, it's always about talking about the future. So the decision is not based on because the customer paid, I have to use it. It's rather, if I don't use it and my customer is unhappy, what is the effect of that unhappiness? Or if I use it and they are happy, what is the impact of that happiness?
Okay. We just got a message from E. Walker. The two competing factors of openness and acceptance are very difficult to reconcile. What is your favorite technique to help resolve these factors?
I don't. So what is the competing? What is
Openness and acceptance.
So what? I mean, so why are they competing? I actually do not see why they are competing.
Okay. Well, we'll follow up with you, Walker, offline then on that one. And then it looks like one last question. Can you elaborate more on formalizing options and revisiting decisions related to them?
Okay. So the idea is that, we tend to dislike documentation. We tend to prefer to anchor to a nominal, a baseline. Okay, and we really like that. But the problem of having, defining baselines, defining nominal solutions is that people get emotional and attached to them. They really, we fall in the trap of saying, well, I am actually making all this effort for this baseline solution, right? Working with options and strategy gives us way more clarity to understand that I'm not working on baseline A to make baseline A work. I'm working with baseline A because by working on baseline A, I fulfill my strategy to achieve success. So therefore, it's better to say I'm working on this element of my strategy, which is option A, and then this other element of my strategy, which is option B, and I'm working in both of them, or maybe one of them, and then I'll have a decision gate for the other one. So working with options and trying to avoid the notion of I'm working towards the baseline is a much better, or it eases a lot the separating the emotional attachment that we have with a specific solution, but really lets us understand that every solution that we're working with is just one element in that development strategy.
Okay, thanks, Alejandro. That wraps up the final Q&A for today's presentation. I apologize if we didn't get to your question. We will contact you directly to ensure that it has been answered. If you have any other questions or comments for Alejandro, don't hesitate to send him an email. His address is on the screen. He would be happy to hear from you with any inquiries you may have. Thank you so much for coming today. We hope that you enjoyed From Decision Analysis to Mindfulness, Letting Go to Improve System Development. Our next webinar will be SE 101, Fundamentals of Architecting with David Long. A reminder, at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. That's all for today. Once again, thank you for joining us and have a wonderful day.